All right, let's start with the homework discussion. Able to see my screen, right? All of you? Okay.
Yeah.
Yeah, we can start in any order. Thais, you want to go first? What are the questions? This today is class 5, right? It's 5. I'll open up the textbook as well. I'm just bringing it up. But if you can call out any specific page number, I mean, where your doubts are going to be.
I didn't know how to solve one question. It was question 6 of review set 8C. It's page 264.
Page 264. Question
6.
of 8C, is it?
Yeah. 8C.
8C. 8C, there's no question. There's no C part, right? Oh, okay. Question 6. Okay. The first 3 terms in this expansion. That one?
Yeah.
All right. Let's do this. I'll just paste the question here. This one, right? The first 3 terms are blah, blah, blah. Okay. All right. So the expansion would be, will the expansion be 1 plus n choose 1. I mean, this is n choose 0, which is 1, right? N times 1 power n minus 1, kx power 1, correct? This will be the second term, correct? Kx. And the term after this would be n choose 2, which is n into n minus 1 by 2 times kx square. Okay. Now this is going to be matching with 1 minus 4x plus 15 by 2 x square. Okay. So ultimately it's just simultaneously solving, right? So we have nk should match minus 4. Nk must match minus 4. And then you have n into n minus 1 by 2 into k square. So that's the coefficient. That must match 15 by 2. Agree?
Yeah, I get it now.
Okay.
Yeah.
Now, obviously, the easiest way is I can put back what k is in the second equation. So k from here we know k is minus 4 by n. Okay, I can substitute that here. So that'll become n into n minus 1 into 16 by n square. That'll be k square upon 2 equal to 15 by 2. If I'm doing some silly mistake, watch out, guys. Let me know. So n gets cancelled. So I have n minus 1 upon n equal to 15 by 16. From here, we can easily get that n equal to 16. 16 minus 1 by 16. Or if you cross multiply, you'll anyway get. So n equal to 16. Put that here. So k is minus 4 by 16, which is minus 1 by 4. Does it make sense?
Yeah.
Okay. What else? Thais, from your side, any doubts?
I had some troubles with oral the binomial extension.
Binomial expansion. Yeah, sure.
Yeah.
Yeah, we covered binomial expansion towards the end. Not in great detail, but yes. Let me know which question, please. We can solve.
I will trying to find it. Just seconds.
Okay. Meanwhile, Moksh, Keshav, you're good with this question 6 that she asked, Sarah asked.
No doubts.
No doubts on this. Okay, cool. Yeah. While Thais is searching, Keshav, how about you? Any doubts from your side?
No.
All okay. Okay. And Sarah, was that your only doubt? Question 8, that one, the one we discussed. Everything else was okay?
Yeah.
Okay, very good. And I'm assuming all of you did like the complete homework, right? Every single question. You're on mute, Thais, if you're talking.
I'm sorry, sir. I can't find it. It was here.
Okay, no problem. But meanwhile, so I'm just, the plan for today is we'll be finishing off permutations and combinations a little bit more, more questions on that, and then we'll get started with quadratics. So that's the plan for today.
So sorry, it was the 10, question 10, on the
Page,
264 page.
question 10, find the possible values of Q,
Yeah.
that one?
Yeah.
Find the possible values of Q. Okay, all right, let's do this. This one, right, Thais? This is the one? Okay. Find the possible values of Q if the constant term in the expansions of this guy and this guy are equal. Okay. So constant term means what? The coefficient, there's no x at all in it. So x power 0, the term which involves x power 0. Okay. So now, how do we know? Let's pick up this one first, right? So how do we know which term will be the constant term? Okay. The very first coefficient will be x power 24, correct? X power 3 whole power 8. The next one will be x power 3 whole power 7 times 1 by x power 3, which will be x power 18. Okay, so with every successive term, the x cubed power is going to reduce by 1. The 1 by x cubed power is going to be increasing by 1. So collectively, the power of x will decrease by 6. Correct? So the next one is x power 12. Okay, and the next one would be x power, x power 6, and the next one will be x power 0. Okay, so what we need is, this is n choose 0, n choose 1, n choose 2, n choose 3, n choose 4. So we need the, I wouldn't say fourth term, it's the fifth term technically, but if you're counting from 0, it's the fourth term. 0th, first, second, third, fourth. So that term would be 8 choose 4. Okay, x cubed power 4, and then q by x cubed whole power 4. So no surprises, the x cubed power 4 and the x cubed power 4 gets cancelled. So we have 8 choose 4 into q power 4. Similarly, in this expansion, you can see it's very similar, right? So it will be not the 0th term, not the first term, it will be the second term, which will be 4 choose 2 times x cubed power 2 and q by x cubed power 2. Thais, you with me completely? Yeah?
Yes, sir. Yeah.
So here also x cubed power 2 and x cubed power 2 gets cancelled. So leaving 4 choose 2 into q square. Now we just have to equate these two, right? So 4 choose 2 so much, 4 into 3 by 2 into 1. Q square equal to 8 choose 4 is so much, 8 into 7 into 6 into 5 by 4 into 3 into 2 into 1. Okay, I'm just writing it explicitly for you guys. Okay, so now we can simplify this. So this is 12 q square equal to, how much is this? This is 24, and then 8 6 are 48. So that'll go 2 times. So I think it's 70 q power 4. Okay, now how do we solve this? So get into the habit of, don't cancel the q, get into the habit of not canceling, right? So
I believe it's 6q square.
sorry, say that again.
It's 6q square.
Oh, 6q square, I made a mistake. 6q square, you're right. 6q square. Okay, 6q square. Therefore we have, in fact, we can cut off one more, right? So 3 and 35. So we have 35 q power 4 minus 3q square equal to 0. Okay, so which means I can take q square common outside. So 35 q square minus 3 equal to 0. So obviously when q square equal to 0, this would imply q is plus or minus 0, which actually there's only one root. I'm saying plus or minus because I want to say that it has 2 roots, right? In total, this is a 4th order equation. Therefore, it has 4 roots. The 4 roots are 0, minus 0, right? Which effectively is the same thing. And then this would be plus or minus square root of 3 by 35, right? If you get right? I didn't check the answer at the back, but if some of you got the same answer, I'm assuming it's right,
Yeah.
right? Okay, and what does q equal to 0 mean? Q equal to 0 means effectively this expansion is just x cube plus 0 whole power 8, which is x power 24. And this is x cube plus 0 whole power 4, which is x power 12. And yeah, this also does not have any constant term. I mean, it has a constant term. You can think of it as 0. Here also it's 0. So in a way, the constant term matches.
So there's another question where they asked us for a constant term, and the constant term was 0 in that case. And at the back, the book considered that there was no constant term. And even in this question, the book didn't give q equals 0 as an answer.
Oh, is it? Okay. I mean, with the way the question is framed, q equal to 0 should have definitely been an answer because the constant term is there in both. It's 0. And the question is, the constant terms are matching or not? The answer is they are matching. Okay, so technically they should include q equal to 0. Okay, does it make sense? Okay, now, because these were small numbers, x cubed plus q by x cubed power 8, I could literally traverse one by one and figure out it was the fourth term, right? Counting from 0 does the fourth term. But we don't have to go through this every single time, right? For example, in another question, in fact, can we do this very quickly for practice maybe? Suppose I have x power, okay, let me just do the x power 5 minus 3 by x square, okay, whole power 100. Okay, now my question is, find the coefficient, or in fact find the term. Okay, find the term, which means the coefficient and the x power. Find the term which has the least positive power of x, right? So what does this mean? It starts with x power 500, the first term, and then it'll reduce, and then finally it'll end in x power minus 200, because the x power minus 2 to the power 100 will become x power minus 200. So the power is going to start from x power 500 all the way till x power minus 200. Somewhere in between, it will cross x power 0, right? So yeah, I'm just explaining the question in case you haven't got it. So find the term which has the least positive power of x. Now, right, so obviously it doesn't make sense to go one term by next and finding out, right? So think about it for a couple of minutes and then we'll discuss. Okay, all right. How's it going, Sarah? Were you able to do it?
I'm not done. I'm still trying.
Okay, but on track, right?
Yeah.
Okay, cool. Okay, Keshav, you're done.
Sorry, my thing was frozen for a while. I just now came back.
Sorry, did you understand the question or were you there when the question was given?
No, my thing was frozen for a while. So
Oh, okay. So my question here, I've written it in blue. So this x power 5 minus 3 by x square whole power 100.
yeah.
So in this one, find the term which has the least positive power of x.
Okay.
I'll give another 1 more minute, guys, and then we'll discuss. Meanwhile, Moksh, can you have your hand raised? What is your answer? Can you call out?
My answer is 100 choose 83 times -3 raised to 83 times x squared.
All right. Shall we discuss, guys? Sarah, are you okay to discuss?
Yeah.
Okay, Thais, you're finishing up, or which are you okay to discuss?
Yeah, I would like to discuss it.
We can discuss, right? So a general term in this expansion using the normal binomial theorem would be what? 100 choose r, x power 5 power 100 minus r, and then minus 3 by x square whole power r. Okay. Now, what is, if you just forget the numbers, if you just focus on the power of x, what is the power of x here? It's 500 minus 5r. And then here it is minus 2r. So 500 minus 5r minus 2r. So this is the power of x. Obviously, when r equal to 0, it starts off with 500. We want this to be a positive power. So we want this to be greater than 0, right? So which means we want 7r should be less than 500, right? So as long as 7r is, okay, I'll just write it this way. So 7r is less than 500. That means it'll have a positive power of x. So let's test where the limit is. So less than 500 by 7. So what is this? 7 sevens are 49. 7 ones are 7. And then some change. I don't care, right? So r should be less than 71 point something. But r is an integer. All of this binomial expansion, r varies from 0, 1, 2, 3, and all that, right? So the maximum r, when this will still be positive power, would be r equal to 71. Am I right? Did I do the division correctly, guys? Ek baar check karo. 7 sevens are 49.
Wrong.
Sorry?
I got value for r is 83.
Yeah. But can you check if I'm doing some silly mistake or you have done some silly mistake?
So I didn't really get the way you're doing, but I just
Okay.
use this ins equation.
Sure. We can go over your solution and maybe I can find if something is wrong or we'll find something inconsistent there. Okay. All right. Which means r equal to 71. So I'm okay with r equal to 71. So if you put r equal to 71, let me just check. What do I get? I get 500 minus 7 times 71, which is 500 minus 497, which is 3. Right? So which means the final power of x will be x power 3. That's a positive power of x. Right? And you can do it using arithmetic.
I think you're going on the wrong track. Because like if you raise the first term to 17 and the second term to 83, you get x squared, not x to the third. I think you messed up somewhere.
X to the third.
Just check by raising the first term to 17 and the second to 83.
Yeah.
You'll get x to the 85 times x to the minus 83, which is x squared.
So sorry, this is your answer, right? This is what you called out, correct?
Yeah, and that's
Okay.
like an square term. You can't have x to the third. I think you messed up somewhere.
Okay. All right. So basically, if you have r equal to, okay, if r equal to 71, okay, so let's see, it starts with 500 and it keeps reducing by it's keep reducing by 7, right? So let's try an arithmetic progression way of solving this. So the
this
next one is
x. Like,
Sorry?
is that x squared or x in the denominator?
x square, x square.
Okay, my bad. I think I'm wrong then.
Okay. Yeah, it's always been x square. Okay. So 500, 493, 486, if you want to do it this way. So again, the same thing, arithmetic progression, right? Another way of writing the same thing. It decreases by 7. You want to see the first positive value, right, of the sequence. And then it ends up being in r equal to, x equal to, the power equal to 3. So somewhere it will go to power equal to 3. This will be the r equal to 0th term. This will be r equal to, so this is r, and this is the power of x, right? So this will be the first term, second term, starting from 0th term, and this will be the 71st term where the power will be x power 3. And the next one after that will go to -4 because the power keeps decreasing by 7. Okay, so
sorry to keep interrupting, but I think you
no
might.
problem. Tell me.
My bad. I realized. I'm sorry.
Oh, no, no, that's fine. So mistakes happen, right? I could have done some mistake as well here, right? No problem. In fact, I welcome interruptions. Wherever I'm making mistakes, please catch me, guys. Okay. And okay. All right. So this is, so I've established r equal to 71. So let me put back r equal to 71 here. So the term becomes 100 choose 71 x power 5 power 100 minus 71, which is 29. And then -3 by x square whole power 71. Okay, and let's verify. So what do we get? So 100 choose 71. So first of all, -1 power 71 will be a negative sign. So I'll put a negative sign here. And then 3 power 71 is the number, right? And power of x, I can just double check once more if it's indeed 3. So 29 times 5 is how much? 145. And then 2 times 71 is 142 with a negative. And therefore the difference is 3. So indeed it's x power 3. So the final answer is negative of 100 choose 71, 3 power 71 x cubed. Sarah, does this make sense to you? Completely?
Yeah, I got x cube. I just didn't know how to find 71 after that.
In fact, you should have got x cubed only after finding 71, right?
It's because I used the arithmetic progression way that you did.
Correct.
Then I got x cube.
And then what did you do? You would have arrived at which is the term number where it's still positive, right?
Yeah, I was still finding that out. So
Correct. Okay. So yeah, but now all clear, right? Thais, is this clear? Keshav, all good? Were you able to
Yes.
get the same answer, Keshav?
Yeah, I think I did.
Okay. All right, cool. Any other doubts, guys? I think that given quite logarithms are all okay. No doubts from logarithms. All okay. We're able to confirm with the answers at the back, all of you. Okay.
So
Yes.
can I give an alternate method?
Sorry, say that again.
Can I give an alternate method?
Yes, please go ahead.
If you take the power of the first term as x and the power of the second term as y, you
Yeah.
can just do x times like 5x minus 2y equals 0 and x plus y equals 100, and solve it as simultaneous. And for this specific case, that'll give you like the value of x equals 0, like the constant term. It won't be an integer value, like an integer r, but you can just check the one over y.
Yeah, so perfectly valid method. The only thing is the last thing that you mentioned, right? You won't get an integer, and it's always a bit of an extra effort to figure out, is it on the left side or on the right side?
Yeah.
Whereas we start with an inequality, it's very clear right from the beginning, what is the value, which side of the non-integer that you want it to be. Okay, but otherwise, fair enough to do that as well. Okay, all right. So, so if that's all in binomial expansion, let's do some permutation combination problems, right? So let's start with permutation combination. So like I said, so there's only two concepts. One is combination, which is choosing. Choosing is double O, right? Choosing, yeah. Okay, so choosing. And other one is called permutation, which is arranging. So there are two problems. One is a choosing problem, one is an arranging problem. In the choosing problem, we don't care about ordering at all, right? You're selecting a bunch of people to form a team, let's say, right? There's no one-upmanship saying this guy is higher, this guy is lower, nothing like that, right? You're just choosing. And that's what we have been doing so far, right? We have been doing n choose r, right? Whatever, 10 choose 3, whatever you want to, right? And what was that? That was n factorial by r factorial into n minus r factorial. We covered that at the beginning of, not beginning, somewhere in the middle of last class, right? So that those are the ones which are the coefficients of the binomial expansion. And why do we get them? Because again, if you do a plus b whole power 5, a plus b, 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 right? And suppose I'm looking at a term which has 3 a's and 2 b's in it. The 3 a's could have come from this a, and this a, multiplying this b and this b, let's say, right? So the a's and b's could have come from different sets of terms. So of the 5 terms, I could have picked any 3 a's and then the remaining 2 b's, and all such ways of choosing 3 a's and 2 b's will all add up to give a term which has a cubed b square, and the number of them would be 5 choose 3, right? Just a recap of what we did last class. All okay on this one? Guys, you're with me completely on this? Okay. Now permutation is arranging. So for arranging, in a way, there's only one number. Let's say there are, in fact, let me not even choose R. I'll just say there are q items, right? Q items, and you have to arrange them in a row like this, one after the other, right? So let's take an example. Let's say there are 5 items, and there are 1, 2, okay, 6 items, fine. 6 items. There are 6 spots here, right? The dash. So let's say there could be A, B, C, D, E, F, G. A, B, C, D, E, F. That's it. Those are the 6 items. If you want to arrange them, I can call any one of those letters to occupy the first spot. Let's say that's D. And then anyone can be the next one, the next one, the next one, the next one, and the next one, right? I could have called any 6 for the first, any 5 for the next, and so on. So it's very easy to see the number of ways of arranging q items in a line is just q factorial, right? As simple as that. Now, problems will involve a mix of both. So you would have a question where there are 10 students in a class. There are 10 students in a class. And then what are the possible ways in which they can win a gold, bronze, silver, right? And this is the, whatever, the podium or whatever you want to call it, right? So the gold, silver, and bronze, right? What are the different ways? Which means, first of all, we'll have to see which 3 could have won a prize, would have been going to the heading to the podium. So that's 10 choose 3. And then further, having decided the people who are going to win are, let's say, the letters P, F, and C, let's say A, B, C, D, E, F, G, H, I, J of the 10 letters. B, F, and C are the prize winners. Having decided that, then you say who is going to be the gold. Let's say I decide that P is going to be the gold, and then F is going to be the silver, and then C is going to be the bronze. So so this is B, this is F, and this is C. So first you have to choose which are the prize winners. That's 10 choose 3. And then you have to arrange the B, F, C in 3 factorial ways. So in other words, it's n choose R times R factorial. So in generalizing this is n choose R times R factorial. But it'll simplify, right? So it'll become n choose R would be just n factorial by R factorial into n minus R factorial. And we multiply by the R factorial gets cancelled. So it's just n factorial by n minus R factorial. So for example, in 10 choose 3 case, it'll become 10 factorial by 7 factorial. 10 minus 3 is 7, which is 10 into 9 into 8. But having done all this, we can just, without even knowing all this, we can just say, there's a collection of 10 people. I can do my choosing and arranging together. All I have is, here's my gold, here's my silver, here's my bronze. I can randomly pick any one of those 10 to come and take the gold spot, any one of the 9 to take the silver spot, and any one of the 8 to take the bronze spot. That itself, it's 10 into 9 into 8. And it's exact 10 into 9 into 8, but in a longer fashion. So you can think of it as either breaking down as a choosing operation first, and then an arranging operation, or directly look at pick and arrange straight away in one shot. Either way, it's the same answer. Right? Both approaches are clear, right? Of course, in a simple setting, this is easy, but there could be problems where you might want to separate out the choosing and arranging. So when we encounter problems like this, we'll see. Is this clear, all of us? Okay. Okay. All right. What else is there in arranging? Suppose we have to form a 5-letter word using the letters P, E, A, B, X, right? P, A, B, X. Some random letters, right? It doesn't have to be meaningful. Then we know there are 5 factorial words that are possible because I can arrange them in 5 factorial ways. But suppose I have a collection of letters like P, E, P, P, E, C, and then I'll do one more P. Okay, so 1, 2, 3, 4, 5, 6, 7. But it's wrong to say there are 7 factorial words. It's wrong. Why is it wrong? Right? For example, forget about P, E, P, B, E, C, P. Suppose it is just P, 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 P. Right? Would it be right to say there are 7 factorial words? No. There's in fact only one word you can make using these 7 P's, namely the one I have written out. So it's wrong to just count the number of letters and say those are the number of words. Then what is it? It's a smaller number, but by what quantity is it smaller? So it is, first I'll give you the answer and then I'll tell you why it is that. So it's 7 factorial upon the number of times there are repeats. So P repeats 3 times, so put a 3 factorial. C repeats, no, so E repeats twice, so it's 2 factorial. And that's it. Nothing, B and C do not repeat. But even there, you can follow that they do repeat, but they repeat 1 time. So it's as if it's a no operation, right? I'm dividing by 1 factorial. So here I didn't do that because effectively each letter was repeating only once. So this was hidden actually from you. The 1 factorials were hidden. But the letters that repeat multiple times, you have to divide by the number of occurrences. Similarly, here, if I do this problem, it will be 7 factorial upon P is the only letter which repeats, and it repeats 7 times. Therefore, you get 1 as expected. Right. Now, why is it 7 factorial by 3 factorial into 2 factorial if you look at it? Okay. Now, for a second, imagine that the 3 P's were different, P1, P2, and P3. Let's say they were marked with a small letter, small number, suffixed. And similarly, let's say the E's are also labeled as E1 and E2. Right? If the letters were differentiable, one from the other, if the P's, if I could say this is P1, no, this is P3, I could identify them separately, then the answer would be 7 factorial. But having done that, so let's say I can come up with one particular word, which is P2, E2, right? B, E1, P1, C, what am I missing? Something, P3, yeah? Okay, let's say this is one particular word. Now, if I write another word in which it is P3, E1, P, E2, P2, C, P1, right? Now, actually speaking, both of these are the same words, right? If the differentiation of that 1, 2, or 3, that suffix was not there, it's just P for P, E for E, E for E, P for P, P for P, right? If I didn't have that suffix associated, these both will actually get treated as one word. But now, because of the suffix is getting treated separately. Now, how many times they are getting treated separately? It's like asking, in this spot, that's the P spot. This is the another P spot, and this is another P spot. In how many ways can I arrange the 3 P's between these 3 spots? That's 3 factorial, right? I could put any one of the 3 P's here, any one of the remaining 2, any one of the remaining 1. All of those 6 different ways of arranging are all exactly the same word, but we are counting them separately. Therefore, we are double counting by 3 factorial times. And similarly, for every one of those, we are double counting the E's. Let's say this is the E spot and this is the E spot, right? So we are double counting by 2 factorial ways, right? So hence we get this 7 factorial by 3 factorial and 2 factorial. Sarah, is this clear? Why we get a reduced number like this?
Yeah.
Okay. Yeah. I think those are the main things. Let's start to do problems, and obviously there'll be more concepts that. All right. Okay. Can we do this? How many ways can 5 letters be mailed? Okay, Keshav, want to take this one?
Yeah,
I'm-
for A, I got 20 because 5 times 4.
Why 5 times 4? What is the logic for 5 times 4?
Because you have 2 mailboxes, and then
Yeah.
in one mailbox you have 5 options, and then the next mailbox you have 4 options, right?
No.
Or
See,
Well, I think
just one second, Moksh, just to be very clear. So this is the 2 mailboxes. I still have to mail all my 5 letters.
oh, okay, I did it wrong. I'll just
Okay. Moksh, I know you're trying to correct him. Just hold on for maybe another 30 seconds and we'll discuss.
I misunderstood the question. Sorry.
Okay, no worries. Okay, Sarah, do you have an answer on this one?
I also did it wrongly, but I mean, I haven't got an answer, but is it 5 factorial over 2 factorial into, wait, can I check first?
Okay, only one thing I'll say. Whatever you do, just do logically. Just don't be compelled to put factorials and NCR, NPR and all that. In a way, think of it that you have not even studied all this NCR, NPR, just like a natural 6th grader. How would you have approached this problem? Maybe a 6th grader would have done it because he didn't know all this NCR, NPR business. Just that way. Forget all the formulas. Thais, want to try?
I tried with the formulas and I had the same answer as Keshav.
Again, okay. Yeah, then you have to explain the formula. What formula did you try, Thais?
The one with n choose r times r factorial.
Okay, what is that n choose r times? So in this case, it's 5 choose 2 times 2 factorial. Is that what it is?
Yeah.
What would that be? That would be if I have to arrange my 5, I have to pick 2 letters only and arrange them one next to the other on my table. So there are 5 letters. I don't care about 3 of them. I only want to pick 2 of them and arrange them on my table, one to the left, one to the right. That would be this answer. But we are not doing that, right? We're picking all the 5 letters are being mailed. Yeah, Keshav.
I was just thinking, logically, one mail can go to one box or the other box. So it's just 2 power 5.
Excellent. Yes, 2 power 5. Moksh, is that what you also got? Okay. Yes. Why is it 2 power 5? So we just logically think. So here's me. I'll take this letter and I'll see where should I go to post it. I decide to go here. This one, where should I post it? Also go here. So this one, okay, I'll go here. So each letter A, B, C, D, E, I have 2 choices, either the letter box L or the right, left or right. So there are 5 different choices. Sorry, there are 2 choices for each one of those letters. So it's 2 power 5, as simple as that. Does it make sense? So there is no factorial business. Doesn't have to be that every problem has to have a factorial. Does it make sense? Yeah. And obviously this will be by the same logic, 4 power 5, right? Because I have 4 choices for each of them. Yeah. Okay. Now only one small modification. Let me just think. Okay. Let's the extension of part B. 4 mailboxes are available. Okay. And every mailbox must get at least one letter. Okay. Every mailbox must get at least one letter. So it's an extension of part B. The regular part B is 4 power 5, as we all know. Moksha, you don't have to raise your hand. I'll make sure everyone gets a chance. Okay, so don't worry about it. Okay, so my extension is every mailbox must get at least one letter. And there are 4 mailboxes, you have only 5 letters. Okay, can you think about it? Again, choose all this factorial and all only as a tool. Don't be compelled. Just think logically. Close your eyes. Imagine you're having these 5 letters. These 4 mailboxes are there. You are going and mailing. What is the operation? How would you do it? Just visualize that. Okay, Moksha, you have anything for me?
Actually, not sure about this, but I think I've got the answer.
Okay, go ahead, please.
First you do 5C4 to see, like what I did is I put one letter in each mailbox and then I decided where to allocate the other 5th. So first I do 5C4 to see which one of the letters would be like 111. So that's 5.
Sorry, I'm not very clear. So you're putting, so there are 4 mailboxes, right? Not 2 mailboxes. So I'll label the mailboxes as, oh, I erase this.
Also 5C4 is my final answer. I'm going to say more of this.
Okay, so these are the 4 mailboxes. Let's call them 1, 2, 3, 4. Very simple, or because I don't want to call 1, 2, 3, 4 because it might involve some numbers. I don't want to confuse with numbers. Okay, so A, B, C, D, E are the letters still. P, Q, R, S are the mailbox. Okay, go ahead. Explain to me, please. Moksha, what are you doing step by step?
Okay, firstly, what I did is I choose 4 letters out of the 5.
You choose 4 letters. So you end up selecting A, C, D, and B. These are the 4 you have chosen.
So that's 5C4 and that's 5, right?
5 choose 4 in 5 ways, which is same as 5 choose 1. In other words, you chose one letter to not choose.
Yeah.
Same thing, right? That's 5 ways. Okay, fine. Now you have this letter E, which is separate, and then this group of 4 letters, which is separate. Okay, now.
Then I multiplied by 4 factorial to like decide which order, like which mailbox each letter goes in.
Okay, so you multiply by 4 factorial because you chose that A would go to R, A would go to R. Okay.
Yeah.
And then C would go to P, and then D would go to S, and then this would go to whatever Q, right? That could have been in 4 into 3 into 2 into 1 ways.
Yeah.
Therefore, you did that. Okay. Then
I chose 4 ways, like 4 possible options for the last letter to go in.
Okay. Then you said E is waiting here, poor guy. Let him put to Q. All right. It could have been either P or R or S as well. The further 4, which multiplies this.
And that's not it. We have to divide it by 2 because, for example, if you put A, B, C, D, and then you put E in the first one, that's the same as if you initially chose E, B, C, D and put A in the first one. So I accidentally counted twice. So you have to account for that and divide by 2 at the end.
Okay, so divide by 2, basically what you're saying is, because in this example, A landed up where? A landed up here in R, C landed up in P, and then D landed up in S, and then B landed up in Q, and then E landed up also in Q. But you're saying whether it's landed as B and E or E and B, it's the same.
Yeah.
Therefore, I'll divide by 2.
Yeah.
Okay. Seems like a natural approach. I'm not saying it's right or wrong yet.
Yeah. You'd have-
Is anyone convinced this is right or convinced it's wrong?
I did something, but I'm not sure if it's right or not.
Okay, go ahead. Describe your method as well, Keshav.
So basically, I looked at it from the perspective of the males. So
Yeah.
first male. So obviously, all 4 males would be filled and 1 would be extra. So
Correct.
as the first male has 4 options, and then I would say next male has 3 options, and then the next male has 2 options. The last male has 1 option. But-
When you say male, what do you mean, the letter or the
Well,
box?
letter. Sorry.
Okay.
So-
Okay. So these are the A, B, C, D, E, the 5 letters.
Yeah.
So the first letter, right?
Yeah. So
When you say the first letter, what do you mean by the first letter? Okay, you mean A. Okay.
A could go to PQ or R. PQ.
A had 4 options. B had that.
B has 3 options. C has 2
So
options.
you're ordering the letters as A, B, C, D, E.
Yeah.
So
And then
you're not.
And then E has to go to one of those boxes. So it has another 4 options. So times 4.
Yeah.
So then we get 4 times 4 factorial, but I'm not sure that's right.
Okay. So you're saying 4 times 4 factorial. Okay.
Yeah.
So 4 factorial times 4.
Yeah.
But the reason, okay, but okay, all right. Let both answers be there. So the only difference, okay, first of all, is the divide by 2 is not there in your case, right? You're not dividing by 2 because you have to divide by that. That's for sure, right? Because in your example, E is finally going to land up in one of the boxes which already has a letter.
Yeah.
Right? It could have, but you're already arranging that A is the first one, B is the second one, C is the third one, D is the fourth one. Okay, fine. So, okay, fine. I'll say with your method as well. So your reasoning is, I've sorted my letters A, B, C, D, E. These are 5. I'll go to A, 4, 3, 2, 1. The last one can be any over the 4. Fine. Okay,
Yeah.
let's hold on to both answers. Now I'll describe another way. Okay, let's evaluate everything, right? Now, the way I like to think about it is, I'll put another color. We all agree that every mailbox has 1 letter, except one mailbox which has 2 letters. So here I am holding my 5 letters, A, B, C, D, E, A, B, C, D, E. So what I will do is, I know that 2 letters have to go to one box and the other letters have to go to separate boxes. So I know I want 2 letters which will go to the same box. I will say I'll choose which 2 to go to the same box. That can be done in 5 choose 2. Namely, I decide that B and E will be together. They'll go to one mailbox, right? And then A will be separate, C will be separate, and D will be separate, right? So 5 choose 2 is telling me in different ways in which I can combine 2. Okay, you're with me so far? Now, Keshav, I want to come back to your answer. You, by saying 4 factorial, you have removed the possibility that A and B can land up in the same box, right? Started putting A, B, C, D in separate boxes straight away. And E was the only one who's going to share it with someone, right? Which means you're eliminating the possibility that A and B could have very well been commonly in one box. Do you agree, Keshav?
Yeah.
Right? Or are others they also able to see Keshav's mistake here? Thais, do you understand the mistake Keshav is doing?
Yeah, I see
Okay.
the difference.
Okay. All right. So this is wrong for that reason. Okay. Now, so what am I doing? I'm doing 5 choose 2. I'm picking which 2 letters are going together. And then now I'll view this as one big letter, sort of, right? One big letter. And this is another letter, another letter, another letter. There are 4 mailboxes and 4 letters now for me. Now it's a very simple game, right? 4 factorial. The first letter, which is actually a combination of both, can go anywhere of the 4, right? 5 choose 2 into 4 factorial. Now, let's compare this answer. So this versus this. So what is the 4 factorial is common here. Okay. And 5 choose 4 is what? 5 choose 4 is just 5. Right. So he has 4 factorial into 5 into 4 by 2, which is exactly same as this. 5 choose 2 into 4 factorial. 5 choose 2 is this, but except that he got it as 5 choose 1 here separately and the 4 here separately. But 2 different ways of doing the same thing. Does this make sense? to both methods make sense. We have to evaluate multiple, and Keshav's method is also good, but good that we were able to spot a mistake. So it's not enough if you are convinced in one way, you should also prove or disprove another way. That's also important. So we proved, again, I'm picking on Keshav, but in general, it could be anyone, right? That's what helps in a group setting. We'll be able to understand other ways of doing something right or even wrong. Right, this is clear. Sarah, go ahead.
Yeah, can you explain again how you got 5 choose 2 in your method?
Yeah, in my method, what am I doing is, okay, again, I'll erase this again once more. Okay, so these are the 5 letters. I'm visualizing. I have 5 letters. I'm closing my eyes. There are 4 boxes. Every box has to have 1, that's for sure, which means what? One box alone has to have 2 letters. Okay, so let me decide which 2 letters will go to the same box. So I will pick P and E are the 2 letters which will go to the same box, and A and C and D will be alone in other boxes. So that's my 5 choose 2. You're with me, Sarah? I've chosen 2 letters which will be together. After that, it's very simple because the number of letters matches the number of mailboxes. Each box has to have 1 letter. So I can allocate in 4 into 3 into 2 into 1 ways.
Yeah, okay.
Clear? And what he did is also clear. What he did was he upfront decided which is the letter that he'll revisit later, right? So that could have been either C or D or P or E. That's the mistake that Keshav did. Keshav said, E will be the letter which will share the box with someone else. Whereas Moksha didn't say that. Moksha said, I will choose which will be the letter that will share. It could have been E, it could have been A, it could have been C. So he's choosing that in 5 ways. 5 choose 1 ways, which is 5 ways. Or you can view it in that way, or you can view it as which 4 letters you want to start first with, or you can view it as which letter you want to consider later. Both are same. The moment you choose 4, you're already choosing 1. The n choose r is same as n choose n minus r. So that's the first step. You're clear on the first step, Sarah?
Yeah.
Okay. After having done that, then the 4 that he has on hand, right? So the first 5 is this. The 4 that he has that are going to be separate. That's 4 into 3 into 2 into 1. Now the other one that he has separated out in the beginning, right? That could land up in any one of the 4. But then we say that if that single letter, so if that shared letter was E and it shared it with P, it could have also been P and E or E and P. Are you with me on that last part? That's very important. The divide by 2 is very important, and why we are doing the divide by 2. Thais, you're clear on the divide by 2? Why? Okay, cool. All right, let's move on. It might seem like we are spending a lot of time in 1 or 2 questions, but these are very, very important concepts. If you understand them well, it'll serve you for the long term. Okay, all right. Okay, all right. I'm just going through which questions we should do. I mean, some of them are fairly easy. I don't want to discuss. Okay, let's try this. 3 Italian, 2 chemistry, 4 physics.
Is one physics book considered the same as one physics book, or are they separate entities?
Good question. What is your read? The way you naturally read it, what's your first this thing?
I mean, to me, I would just say physics books are different.
Different, yeah, different, correct. The natural tendency, go with natural tendency if it is not very clear. And yes, he should be qualifying for physics books by different authors, something like that. Okay, Sarah or Thais, can you do the first one? If there are no restriction, what is the answer?
I think that if there are no restriction, I'm not sure. I could just multiply 3 factorial by 2 factorial by 4 factorial.
3 factorial by 2 factorial by 4 factorial.
Yeah.
Explain this. I'm not saying it's right or wrong, but explain why.
Because I can arrange oh wait, I'm not sure anymore.
No, don't judge by my face. I have a poker face. You might very well be
Okay.
right, but I want you to explain.
I can arrange the 3 Italian books in 3 factorials way, and then I can arrange the 2 chemistry books in those 2 factorials way, and then the 4 physics
Okay.
books.
But
My
okay,
head.
Sarah, do you agree or disagree with her?
I mean, the way sorry. Okay, the way I saw it, even though they said 3 Italian, 2 chemistry, 4 physics, they're all ultimately different books by different authors, as we said. So then I just did 9 factorial because I just
Okay.
have 9 different books I can arrange in 9 factorial ways.
Okay, so what Sarah is doing is they're all different books. I don't care what's written inside. It's 9 different books, 9 factorial ways. Okay, Sarah, what do you think about her method then? What's wrong? Are both the answers same then, or is anything wrong in hers then? I understand what you did, but what's wrong in what she did then? Moksh, can you tell what's wrong in? Yes, in fact, Sarah is right. It's 9 factorial. Moksh, what is wrong in what Thais did?
Thais assumed that firstly, Thais assumed that the books must stay together by subject, which is the option C.
Correct.
And
In
one
a
more
way,
thing-
Thais answer. Hold on 1 second, so that she also understands, right? So you forced that the 3 chemistry books must be together and they must be first, or whichever the 3 Italian. Sorry, it never said that, right? Yes, go ahead, Moksh. Sorry.
And one more thing, she failed to assume, like, to account for the possibility that she said 3 factorial times 2 factorial times 4 factorial. And that's making it into blocks of Italian chemistry and physics. But what about the order of those blocks? That would be times 3 factorial at the end.
Exactly. Right. So 2 mistakes you're making, Thais, that the Italian books are all together, chemistry books are all together, physics books are all together. That's one. The other mistake is that the Italian books is the one that goes first, and then the chemistry books, and then the physics books. Right? There'll be a very neatly arranged shelf, which is what an ideal student should be putting it. But that's not the answer to the question. Does it make sense, Thais? Okay. So well done, Sarah. Okay. B part, Keshav. If the chemistry books must remain together.
I did 9C2 times 7 factorial.
9 choose 2 into 7 factorial. Explain your answer.
Well, there are 9 spots. I think there's 9 spots. Yeah. So there are 9 C2 ways that actually no, that's wrong. Okay.
Okay.
Okay, wait, I'll just solve it again. I don't think I've done it right.
All right. Yeah, all of you think through exactly what's happening. Visualize. Don't blindly put factorials and choose 2 and all that. Okay. So visualize. I'll give another 30 seconds. Keshav. Yeah, Keshav, you have something now?
I think I got 8 factorial, but
Explain. Very close. Okay, explain, please. And I'm sure you'll figure out.
yeah,
as we do.
yeah. So I did. I put 9 shelves, and I said there is, you can, for them to be together, you can have you can have first and second book, second and third book, third and fourth book, fourth and fifth book, and all the way to eighth and ninth book. So I think that's 8. I don't know if I made a mistake, but and then you have 7 options, and then from that you can choose. You can do 7 factorial.
Yeah, you're almost right. Moksh, any mistake in what he's doing?
So for this question, I like to use the method you used for the previous question. Like,
Fine, we can
if you
compare different
consider-
methods. You want to first, you have 2 options. Either you can say out your method,
Okay,
or you can agree or disagree with his method.
I disagree with this method.
Okay, all right. First call out your method, then we'll come back to his. Yeah.
If you consider the 2 chemistry books as one big block, you get
Okay.
3 Italian, 4 physics, and 1 block. So that's 8. And then
Okay.
8 so far I agree. But Kesha forgot to arrange the books inside that block. It can be the 1 chemistry book first, second chemistry book second, or second first, and another second.
How
Like,
do you correct it?
you have to multiply by 2 factorial.
Yeah. That's I understood that as he started explaining. Yeah.
That's exactly one small thing you were missing. You
Uh,
put the 2
yeah.
chemistry as one
but
block.
it could be 1 or first or second. Yeah. Now I know.
Exactly. So C1, C2 or C2, C1. Okay. So Thais, is this clear to you as well? Okay. So
Yes,
yeah.
sir.
Yeah. So 2 chemistry is putting as one block, and then he's viewing them as 8 different books, 8 factorial, and then open that block alone and then arrange the C1 and C2 separately. Okay. All right. Last part. The books must stay together by subject. Sarah, can you take this?
So just like how Thai said before, won't it be 3 factorial into 2 factorial into 4 factorial, but then this also can be arranged in 3 factorial ways. So will it be into 3 factorial or?
Okay. Think a bit more and then say whether into or divide or don't do anything. You have to decide that and tell me. Have you decided what to do?
Into 3 factorial?
Into 3 factorial. Yes, rightly said, right? So 3 factorial ways of arranging the Italians, 2 factorial of chemistry, and then this. So right now you've arranged them as block of 3, right? This is the C block, and this is the P block. And ICP themselves can be arranged in 3 factorial ways. Therefore, it is this, correct? And the first answer that Thais gave was, this was if the Italian books must come first, and then the chemistry books, and then the physics books. Okay.
So
Now-
can you explain again the thing cut out when you were speaking?
Oh, nothing, very simple, right? So arrange the 3 Italian books in 3 factorial ways. Arrange the 2 chemistry books in 2 factorial, arrange the 4 physics books in 4 factorial, and then between them, the ICP and all can be arranged in 3 factorial ways,
Oh, okay. Got it.
right? Times 3 factorial. Okay. All right. Now, I'll obviously ask a few more variants of this. So the next part D that I have, so for all of these are very clear, right? So part D is no 2 chemistry book must be adjacent. Okay, can we try this? No 2 chemistry. Sorry, there are only 2 chemistry books, right? So I'll change this. No 2 Italian books, because there are 3 of them, right? So no 2 Italian books. No 2 Italian books must be adjacent. Question is clear, right? If question is not clear, ask, please. Again, multiple ways of doing this. Okay. Moksh, you want to take this?
I'm not 100% confident in my method, but this is what I did. I took one, like, again, I'm using a block method.
Any method, yeah.
First you take one Italian book, then any other book, and then a second Italian book. Okay. So first you
So
would
please repeat. I didn't understand.
first you're taking in this one block as one Italian book, then another book, any other book, and then a second Italian book.
So I2, then C3. Sorry, there's only C2, right? There's only
Yeah.
2 chemistry book. Okay. So sorry, what happened? Okay, I2, C2, and then I1. Okay. And then what are you doing with this?
Okay, firstly, there are 6 ways to choose which book goes in between. There's like 7 other books, but you can't put an Italian book in between. So you have to choose out of 6 other books. Make sense?
Okay.
Then you do 3 choose 2 times 2 factorial to choose like which Italian books will go in the block and in which order.
Okay. So so 3. Okay, you're deciding which 2 Italian books to pick.
Which is
right?
same as one, yeah.
All right. Let's say of the I. In fact, I'll just change it to I3 so that it's clear that there are 3 of them, right? And
Yeah.
then having chosen I1 and I3, you decide to put I3 first and then I1, right?
Yeah.
That's 2 into 1. And then of the remaining 6 books, you have decided which book, namely C2, has come in as the book in between.
Yeah.
Okay.
That's 6 times 6.
Oh,
And
whatever, numericals, we'll do it later. Don't worry.
and then you have the block of 3 and then the 6 other books. On inspection, and this is kind of flawed because you can put Italians on the other side of the Italian book. So I'll have to think of another method.
Not
I
only
think
that, not only that, and why did he assume that's only one non-Italian book between the 2 Italian books? I could have a C2 and a P1 followed by a P3, and then I can have the I1, right?
I think maybe you should take, honestly, I'm not sure. It's the
Okay,
same
fine,
kind.
fine. Okay, so at least you agree that the method is wrong. Okay, good. Keep thinking. Thais, you have something so far? But you understand that his mistake is method is flawed, right?
I understand his mistake, but I don't really know how to do this.
Fine. Keep thinking. Keshav, you have anything? Sarah, you have anything? Again, visualize. If you visualize, you'll see it. It's like a puzzle. There's no, I mean, there's math, but it's more like puzzle solving.
So I think I've got a way, but it might be slightly inefficient.
Okay, let's not worry about efficiency. Let's go ahead, please.
Okay.
Hold on. Before you take that, I want to give anyone
Okay.
else has anything. More, Keshav, you have some first try.
I'm trying to figure out, because if I put one Italian book in the first spot, then I have 7 possible ways of putting the other Italian book. But oh wait, I have to take into account 3. Okay, I think I've just done something wrong once again.
Okay. Moksh, why don't you also think for a minute, right? And then we'll discuss again. Let's give everyone 1 more minute to think. Okay, Moksh, you have something to share?
Okay. Well, I was to find what how many scenarios if there were no 2 Italian books must be adjacent.
That's the question. Yeah.
So why not we take all possible scenarios, the answer to option A, and subtract all scenarios where Italian books are adjacent.
Okay.
It's slightly inefficient, but yeah.
Okay.
So
On
first
that, hold on 1 sec. Sarah, what do you think about that suggestion that he has? He'll take all cases and then he'll subtract cases where fill in the blank, Moksha. Subtract the cases where?
Italian books are adjacent.
So I have a method.
Oh,
I'm not sure if it's right.
Okay, okay, Keshav, before you go to the method, in what Moksh said, there's a small mistake. So he said,
I mean, obviously, I'm accounting for cases where all three are together as well. I haven't.
exactly, right?
Yeah.
He said count all the cases and subtract those cases where the Italian books are together. Right? But there are multiple cases. All three Italian books could be together, or two of them are together and one of them is separate somewhere out, right? So all those extra confusion gets added. Correct?
Like that's why I said it's kind of inefficient. Like if someone's got that method, they should explain that.
Okay, sounds good. Keshav, what you were saying something, please?
I think it's very wrong, but it's worth a shot.
Fine,
So
please go ahead.
I guess if I start with the Italians, the first Italian has 9 spots to pick.
Okay, first
right?
Italian has 9 spots to pick. Okay, 1, 4, 5, 6, 7, 8, 9. Okay, so the first Italian, when you say first Italian, I1, right? The Italian I1,
Yeah.
I1 lands up here.
Okay. So the next Italian can only go 2 away from it to the left or some spot like with 1 in between.
Mhm.
Oh wait, I forgot to account that they can have 2 spaces in between.
So I think I got a better method. I think I actually got a good method now.
Okay, go ahead, Moksh. Yeah.
Okay, could you please? You've drawn 9 blanks, right?
Yeah.
Could you draw like erase 2 of them?
Erase 2 of them. Okay.
Yeah.
All right. I'll erase this guy and this guy.
Okay. So can you?
In fact, I mean, you wanted 2 adjacent one to be erased, or
like
what is? Sorry.
I would prefer all 7 of them to be in the line for.
Oh, okay. 1, 2, 3, 4, 5, 7. There are 7. Okay. There are only 7 I've drawn now. Okay.
You can put books in the 2nd, 4th, and 6th slots, right?
Which books? The Italian books.
Yes, Italian books.
So you're putting here, 2nd,
And
4th, and
6th.
6th. Okay.
So we have to place the remaining 6 books in the other 4 slots. And before we start doing that, I'd just like to say, I am aware you can have 0 books at either end. That's also a possibility. Okay. So first, let's assume that at both sides, there's 0 books.
Both sides there's 0 books, namely here and here.
Yeah, that's blank. That's blank. Okay, then you just pick. I believe it would just be.
Hold on 1 sec, Moksh.
Yeah.
Why do you have to allocate? So by your method, you're saying an Italian book cannot be at the far left.
No. I think this is one possibility. There's a lot more possibilities. That's what I'm kind of.
All right. So yeah, we agree. If it's a lot more possibilities, then obviously let's not get into that, right?
I'm just first I'm examining the possibility where there's nothing else at the end. Okay. So for the first 5 books, like you have to do 2 to the 6. 2 raised to 6, because each one of the 6 books can go into any of the slots, any of the 2 slots in the middle.
I'm not at all clear. What is it? 2 power 6? It's not like a mailbox, right? Where 2 books can go to the same slot. So where is the power coming from?
Okay, there's 6 books left, right?
There are 6 books left. So far, you've allocated the 3 Italian books to spots 2, 4, and 6.
Yeah.
Now, and from here, carry on, please.
There's nothing in the end slots. Okay. So the first book it can go either in the 3rd slot or the 5th slot.
Okay. So the first, the non-Italian book can go to the 3rd slot or the 5th slot.
Yeah.
Okay.
Second can also go in the 3rd slot or 5th slot.
Okay.
2 to the 6. Like you keep repeating this until 2 to the 6. Does that make sense? I'm assuming multiple books can go in the same slot. I'm assuming
How can multiple books go to the same slot?
What
does that mean?
Like it's a slot per se, because we're messing with the definition. By that, we remove 2 to the 7 slots, and they are cutting out the end slots as well. Think of it like spaces, not slots for 1 book each.
But if you put 2 in the same slot, then finally you'll have confusion when you unravel it, right?
And yeah, it's a bit confusing and long, and then you have to do
all right. We have had enough discussion.
I have one more idea, fam.
So I think you should listen to Keshav's. This is very
okay.
No, I don't know mine's right, but
I have
a bit of addition in this. So basically I thought about it. So if one Italian book is at the end, then there are 7 possible ways to pick the next Italian book for it to not be adjacent. So if I pick one in the end, then
So one second, let me just draw it. So there are 9 spots, right? You want me to draw 9 spots?
yeah, 9 spots.
Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then want
So
to put I3 here, let's say.
yeah, so there are 2 possible ways to pick some. So I could, if I have that on the end, then I have 7 other possible spots without
Yeah.
the one next to it to
Yeah.
pick the next Italian book.
Mhm.
And then if I do that, then I have 5 possible ways to do the third Italian book.
Do you have always, for example, suppose I put I1 here. So I have 1, 2, 3, 4, 5. Okay. All right.
Yeah, so then I'll do 9 times 7 times 5. And then 6 factorial.
What is the 9 times 7 times 5?
So
have-
9 choices for the first one.
But
7,
you're saying, there's no choice for the first one. You're putting it the far left. That's when you are forcing it to be in the first.
So I think
so
he's
then I was going, then the addition comes in. Then I have plus 9 times 6 times 4 times 6 factorial.
No, where is the 9 times here in the first? You don't have a choice. You are putting it in the first spot. Where is the 9 times coming from?
so in the example he gave, he's saying there's 7 choices for the for the second Italian book and 5 choices for the third Italian book and multiplying that by 9. But that's not really.
Where is the multiplying by 9? I'm not even clear that
He's
multiplying by
assuming that if he puts the first Italian book in any of the other slots, you can
yeah. So that means it's 2 times 7 times 5 times.
And that's not really also accurate, because if the second Italian book goes in the 8th slot, for example, there's
No, but then I am accounting for that. Then I do I have.
Okay. But so all the methods we've given so far seem really slow. Can you just give us?
Yeah. So we agree that, Keshav, do you agree that it's going to be longer? Just 1 second. Huh?
Yeah.
Someone is at the door. I have to ask my kids to pick it up. Okay. All right. So Keshav, you agree that will also be convoluted. Do you agree?
Yeah.
Okay. All right. Let's discuss. Okay. So actually, it's very simple if you think about it. Okay. We don't want any 2 Italian books to be next to each other. Correct. So let's fill. How many Italian books are there? There are 3 Italian books, right? Okay. All right. So let's fill all the others. 1, 2, 3, 4, 5, 6. These are the 6 slots, or 7. Sorry, 6. There are 2 chemistry and 4 physics, right? We'll arrange the 2 chemistries and the 4 physics in 6 factorial ways, because they're all different books. Doesn't matter what subject and all, doesn't matter. There are 6 different books. We arrange them in 6 factorial ways. Now, what do? There are 7 gaps where we want to pick where the Italian book should go. We'll choose 3 of those gaps. Let's say it could be this, it could be this, and this. Right? I've chosen of the 7 gaps, including the left extreme and the right extreme. There are 7 gaps because there are 6 books already placed. I choose 3, and then I arrange the 3 Italian books in 3 factorial ways. So it's 6 okay, I have to multiply this, right? The 6 factorial ways of arranging the chemistry and physics books, choosing 3 of the 7 gaps, arranging the 3 Italian books. Is this clear?
Yes, this makes sense.
Makes sense? Keshav, does it make sense to you as well?
Wait, how would there be this many gaps? Because that doesn't add up to 9.
Okay, there are 6 books, right? There are 5 gaps in between them. And then there's one to the left and one to the right.
That doesn't have to be, each gap doesn't have to be filled up. It's not like you have to fill up all gaps. Like gaps represent possible spaces for Italian books.
Correct.
And not all of the possibilities are going to be filled in.
In fact, exactly 3 of those will be filled.
Okay.
Is that clear, Keshav?
Yeah, I think.
No, I don't want I think. You have to be solidly clear. What's bothering you? Let's clear it off.
I don't know. I just feel like because you put 1, 2, 3, 4, 5, 6, 7 gaps, there are 6 spots in the middle that adds up to 13. But
Yeah, but Keshav, not all of them are going to be filled. It's not going to be a book in each of those.
oh,
Yeah.
okay.
Right? So
Right.
P1 has landed up here, right? You're clear, right? So this is C2, and then P3 is here, and then C1 is here, and then P4 is here, and P2 is here. After doing that, we have these 7 gaps, and we picked this gap, right? This gap and this gap for the eyes.
I thought they're all like tightly. I thought they were all just like you only have space for those 9 books, so then you can.
Yeah, there is only space for those 9 books. Yes.
Oh, but okay, okay, got it.
And then we'll put it in the shelf
I got it.
properly. On the table, we'll lay it out. There is enough
Got it.
space on the table.
Got it,
After
got it.
deciding the arrangement, we'll pack it nicely in the
Yeah.
shelf.
I understand.
Is this clear?
Yeah, this is a good method. So.
All right. Now let's do Sarah, you're clear, and Thais, you're clear as well, right?
Yeah.
Now this last one is what I think Moksha did one mistake, right? So that will lead to another question. The Italian books must not all be together. Note that these 2 questions are different. Must not all be together. Question D and question E are different. You understand the difference between question D and E?
So 2 of them can be together.
Exactly. Right? Must not all be together. 2 of them can be together, as Keshav rightly put. They don't have to be, but they can be.
It's just that all 3 of them can't be together.
Exactly. Correct. But they can be completely apart, or 2 of them can be together, 1 can be apart. Thais, you want to get us started?
I think my method is wrong.
Okay. No
I
problem.
tried.
Okay. Now,
Um,
if you're clear that your method is not going anywhere, we don't have to discuss. No worry.
Okay.
Sarah, what about you?
I'm still trying to do it.
Okay, Keshav, you have something?
I'm doing the previous one you did where they all can't be together, and then I'm adding that to something else. I don't know if that's. I'm trying to figure out the case
Okay.
where 2 books
Okay.
are together and 1 is way.
Okay, all right. So yeah, that's one way to do it, Keshav, and you'll add it to this. And obviously there's a shorter way, but we'll validate that. Okay. What Keshav is telling is we already did part D, right? To that, we'll add the case where 2 Italian books are together, but 1 alone is separate. Okay. Between that and this, if you add, you should get the answer for part E. Okay. That's what Keshav's approach is. Fine. Moksh, you have something?
Yeah, so I can actually use one method that I tried for question B to get question E. Like, if you take the case of no restrictions and subtract all the cases where all three are together, you get the answer for E.
Perfect. Yes.
Yeah, that's like what I was about to do.
Yeah, so this
Right?
is a easy method. You got
So it's
three.
part A minus sort of like part B, but instead of chemistry, it's Italian, right? So,
Yeah,
right, you can think of B for Italian. I'll just put like this, B Italian, right?
Yeah.
The case where all the Italian books must remain together.
Yeah.
Thais, are you clear with this approach?
Yeah, that's why I tried to do.
Okay, very good then. Then you should have called out, no problem. Okay, so 9 factorial, which is the part A, minus the case where all the 3 Italian books must remain together. Thais, can you answer that now? So what will this answer be? Where all the 3 Italian books must remain together, just like we did for part B.
I don't remember the method for part B. Wait.
Just 7 ways, right?
7 ways?
Because
Why 7 ways?
you can have 3 together, 1, then 2. It's just 9, choose 3 again. Oh no, 9 P3.
Okay.
No.
No,
First of all,
no. It's just because I just drew 9 and I just 3 could be one part and then next 3, the next 3, next 3
So
together.
it's
okay.
10.
So one word of caution. Try not to use P. 9P. Okay, so just so that others are aware, 9P3 is 9 choose 3 into 3 factorial. I intentionally made sure I'm not talking about P because it's more confusing. Think of it as choosing and arranging. If at all.
I just counted this
Okay.
spots, which I got 7.
So should I say another way?
No,
Right.
not yet, Moksha. I want Thais to first complete it. Thais, you said you forgot how to do B, right? Try to recap. Just go through the paces. What did you do to make sure the chemistry books remain together? What did you just do? Just visualize. You didn't care about physics and Italian in that case. You wanted to hold the chemistry books together, and there lies, if you say it out loud, you have the answer, that itself. You bought a box and put the
so
chemistry books
it's-
together.
7 factorial.
Okay, now you're doing the Italian directly, or you're doing the directly, we can do the Italian, right? So,
Yeah.
okay,
Oh,
in fact,
So it was
right. In fact,
Six.
I'll just change this. Okay. Right, now we'll do the B part. Just answer the B part for me. The Italian books must remain together. Answer for part B is what? Yeah, go ahead.
So it's wait, 2 there. So 3 slots left. So it's 6 factorial.
Okay, whatever you tell me, but you have to justify. I'm not going to say yes or no. What is the 6? You tell me.
Because they are wait. So they must remain together. So if they must remain together, so it's 3 slots. 6 factorials times 3.
6 factorial times 3. Okay, tell me what is 6 factorial? What is the 3?
Because
Explain each number. What is the 6?
yeah, because there are so 3 slots are used. So there are 6 slots left, and you can rearrange the 3 books in those 3 slots.
Not very clear. Okay, Keshav, do you want to answer part B? The 2 Italian books must, but the Italian books must remain together.
I just got 7
Just
because
7?
I put them in a block, and then like I just counted, so there could be 3 and then 3. I just counted my fingers. So I don't know if I'm right or not.
I'm not understanding you to judge, right? What is the 7? I'm not clear what your 7 is.
Can
Well,
I
yeah,
draw?
you can draw. You want me to draw? In fact, all of you enabled to share. Can you
Like-
draw something or no?
Yeah. Okay, then I have like I have 9 spots.
Okay.
And then the 3 together could be here, or it could be like this,
Yeah.
or it could be
Wait,
these
can I-
3, then these 3, then
Yeah.
these 3, then
Yeah.
these 3, then
Okay.
these.
So there are the 7 groups of 3. Okay.
Yeah. So that's the only way they all 3 can be together. So
And once you decide, that's it. Don't you have to arrange them? And
yeah.
don't you have
Oh,
to,
yeah. So
and
then
don't you have to arrange the remaining books, the
the
chemistry and
7, the 7 times 6.
7 times 3 factorial, you mean?
Uh,
But what about the physics and chemistry books? Those also have to be arranged, right? For each of them.
oh,
So I think he accounted for that. While like if you take the Italian books as one group, when you do that's 6 other books in one group. So by doing the 7 factorial, he's arranging the other
He's
books.
not doing 7 factorial. He just said 7,
Oh my bad.
right?
Wait,
Yeah.
can I?
Yeah.
Okay,
Go ahead,
yeah.
Sarah. Go ahead, Sarah. Yeah.
So
yeah.
I think it'll be 8 factorial into 3 factorial because
Okay. 1 second. I'll write your answer. So for part B, you're saying it's 8 factorial times, what is it again?
3 factorial.
3 factorial. Okay. Explain your answer.
So firstly, there's okay, wait, I think it's 7 factorial into 3 factorial.
7 factorial into 3 factorial. Okay. Explain.
So there's 2 chemistry and 2 physics books. These are just all different books.
Yeah.
That's it. And then there's a block of Italian books. So then these are like, so then 6 plus 1, 7 factorial ways they can be arranged. And then in that Italian block, it can be arranged in 3 factorial ways because
Perfect. Perfect. Does it make sense, Keshav? Right? Right? And Thais, did you understand that as well?
Yeah, the second
Okay.
times when I tried to draw the problem, I found
Yeah.
the 7
So the
factorial.
C1s, very good. So C1, C2, P1, P2, P3, P4, and this block of I, right, which has 3 entities within that. So that's 7 entities, which is 7 factorial ways. Sorry, C1, yeah. I missed P2. Okay. Okay. So there are 7 entities. You arrange them, and then you open the block and arrange the I's in 3 factorial ways, right? Or Keshav, to what you started doing, that's also fine. You didn't complete it. You identified there are 7 possibilities of selecting 3, 3, 3. Having selected one of them, you arrange them, which is 3 factorial ways. And then the remaining 6
Yeah,
books,
6 factorial. Yeah.
that's your 6 factorial. And this is same as what she has.
Got
And
it.
the
Yeah.
7 times 6 factorial is her 7 factorial. Is that matching? Does it make sense?
Yeah, got it.
Right? So finally, as Moksh started off, so it's subtracting the B part, which is whatever the answer that we just said, 7 factorial times 3 factorial. Okay, numericals anyone can do, no problem, right? So we can simplify, for example, I can write it as 7 factorial times 8 into 9 minus 3 factorial, right? I can do some simplification like this. So 72 minus 6, 7 factorial into 66, something like this. Okay, all right, almost done. Now, I want you to revisit, I'll erase all of this, right? I want to revisit all the 5 questions, going back to, again, one of Keshav's question. He said, do the Italian books all, are they identical or they're different? Now, I'm going to say they're all identical Italian books by the same author, the same book, right? So 3 identical Italian books, 2 identical chemistry books, and 4 identical physics books are there. Okay. Now we are going to do all the problems. No restriction. How many ways to arrange? Thais. I mean, all of you do it. Okay, I'll decide who to give this to, but maybe I'm thinking Thais, you should get this. Right? The only changes now, we are going back and changing all the books to be identical. I mean, of a particular subject. The 4 physics books are identical, inspired by Keshav's doubt at the beginning. So these are all good. They're all good doubts to have, and you can make new problems based on them, right? And you can solve. We're almost up on time, but we'll just do this and then we'll wrap. Okay. I want to go quick in the interest of time. I'll have to wrap and have to the next class also, right? So, okay. Thais, you have something, or should I pass it on to someone else?
I'm not sure, so maybe to like gain time, we should pass to someone
Okay,
else.
Keshav. So,
I got 9 factorial over 3 factorial times 2 factorial times 4 factorial.
Yeah. We discussed that at the very beginning. It'll be 9 factorial if the letters were distinguishable, but these 3 are identical letters. Therefore, we divide by the number of repeats, right? 3 factorial, 2 factorial, 4 factorial. Okay, that's part A. Part B, if the chemistry books must remain together, again, I'll finish it off, guys. So that it's, so again, we'll put the chemistry books together as one block, right? Now, the problem reduces to you have a total of 8 entities. There are 3 entities here. There's 1 entity here. There are 4 entities here. So it's 8 factorial, of which these 3 are repeats. Therefore, 3 factorial. These 4 are repeats. Therefore, 4 factorial. If I open the box, the 2 chemistry books are identical. Therefore, there is no multiplying by 2 factorial anymore. It's just that. Does it make sense? I put the 2 factorial and erased it to show that we are not multiplying by 2, because when we open the block, the 2 chemistry books are looking identical. There's no left, right anymore. They have to be together. There's only one way in which they're together. They're already in the box. Does it make sense? Why we don't multiply by 2 factorial? Sir, are you with me? Okay, so that's the B part. C part, if the books must stay together by subject, right? That means what? We first have to decide between the I group and the C group and the P group in what order they'll be. That's 3 factorial. Having done that, there's only one way and one way and one way in which you can arrange all the I's, arrange all the C's, arrange all the P's in that block, because they're identical. You've decided that the C group must come first, then the I group, and then the P group. Having decided that, the 2 C's are all here, the 3 I's are all here, the 4 P's are all here. There's nothing more for us to arrange. So all we have to do is arrange the group itself as in 3 factorial, because there are 3 different groups. Keshav, does this make sense?
Yeah.
All of you with me, right? Okay, all right. And then no 2 Italian books must be adjacent. Okay, again, the same principle. No 2 Italian books must be adjacent, right? So I have the 6 slots for the chemistry and the physics. 1, 2, 3, 4, 5, 6, right? So there are 2 C's and the 4 P's. So first I'll arrange them. That'll be 6 factorial by 2 factorial into 4 factorial ways. Having done that, now there are 7 gaps as before. We choose 3 gaps. Let's say we end up choosing this, this, and this, right? There's nothing more to do. There's no 3 factorial multiplying anymore, because once I choose the gaps, I have to put the 3 identical Italian books there, right? There's no multiplying by 3 factorial anymore because all the books are identical. Are you able to see the parallel with the earlier problem now? Okay. And then the part E, where the Italian books must not all be together, right? So we'll do the same way. We'll do the part A. I'll erase this. We'll do the part A minus, so for the part E is part A minus the cases where the Italian books are forced to be together, right? So we have a couple of C's. We have the group of 3 Italians here, right? And then we have the P, 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 and P, right? So there are total of 6 entities, right? No, 7 entities, sorry. The 2 chemistry, the 4 physics, and the block of Italian, right? You can arrange them in 6 factorial upon 2 factorial into 4 factorial, because the 2 chemistries are identical. The 4 physics are identical. This block, there's only one of that block. There's no, right? If at all anything, it's 1 factorial. And then we open the block and there is no arranging because all the Italians are identical. So it's that. Are you able to visualize this completely, guys? Okay, all right. We'll stop here. I wanted to get started on quadratics, but although the number of questions we did was less. I think conceptually we covered a lot of ground in permutation combination today, right? We'll do the homework problems. Obviously, that's when you'll really sink in. Okay, we'll do quadratics tomorrow, guys. Very important topic. Don't miss. Okay, see you. Bye.